Hello and welcome to What is Machine Learning? Let's get started. First, a few introductions. So why are we here? We are here to quickly learn what machine learning is. So you can go to your next meeting prepared to have an understanding, if not a conversation, about machine learning. This webinar is being presented by LeadScores, a Seattle-based predictive lead scoring company, with a special focus in the EDU or education sector, amongst other services provided. My name is Harry Brailsford. I'll be your host. Let's go ahead and get started. The short answer for what is machine learning is Netflix. It just knows what you're going to purchase. When I describe the concept of machine learning, I simply ask if the individual uses Netflix for entertainment. The answer is typically yes. So, how does Netflix just know what movies you might like or enjoy? It's called machine learning. Technically speaking, machine learning is all about testing. So it starts with training data, which in this case would be your historic purchase behavior at Netflix, and then applies predictions to what you might like. When you make a predicted selection, your answer is noted, and so are your declines. Machine learning is a subfield of computer science that is the study of pattern recognition and computational learning theory and artificial intelligence. But don't be embarrassed if you didn't know that. By the end of our conversation today, you're going to be able to go into a meeting and have a conversation and understanding about what machine learning is. Let's talk about an EDU or education example. So here we're focusing on a mid-sized university that uses machine learning as part of a predictive lead scoring strategy for recruiting students. In talking with the university, I was told by an executive that it's an enabling technology. He said, we use high technology to gain prospective students, but we're truly student-centric. The online university is benefiting the students rather than blasting them with a message. An example, he goes on to say, would be we use machine learning to better understand our audiences, so then we can isolate like groups to deliver ads that are relevant to the person or the group of people. So, for example, they do not target those seeking a trade certificate or only an AA degree. It's all about relevancy. It's also improved the internal processes of the admission department. So the machine learning has helped the school isolate those who need to talk to someone now about starting school. That would be a high lead score, versus those who just want information. That would be a low lead score and maybe go into more of a nurturing campaign. And then the improved student experience. By having a smarter university using machine learning as a core tenet to their operations, the university has higher customer satisfaction scores. So let's talk about the curriculum and decision support for teachers. IBM has done a lot of research in this area, and they said on the academic side, quite simply, the classroom will learn you. The talks about the classroom that will use the technology tools based on machine learning is so they can understand each individual student and create a custom curriculum in the cloud. You could think of it as machine learning meets the massive open online courses. It's one way to view it. They go on to say that IBM envisions educational institutions adopting cloud-based cognitive systems to collect and analyze all of the data over a long period of time. So basically what we're saying is that they can identify students who are at risk, those who are struggling, as well as insight into the interventions needed to overcome these challenges. The machine learning could also be a system where it could couple a student's interests and goals with data on their learning styles so teachers can determine what type of content to give the student and what type of way to present it. Let's dig a little bit deeper. There's three elements to machine learning. Number one, a pattern exists. For example, rating movies on Netflix has a pattern. Number two, we cannot pin it down mathematically. That's why we're using machine learning to learn from data. And then number three, obviously, we have the data. Machine learning always starts with the data. Your goal is to gain knowledge or insight from that data. There's some amount of automation in this process. So instead of trying to divine the wisdom manually, you're applying an algorithm to help answer the questions being presented. And the automation is, of course, a computer. But I will say this, machine learning is just not machines. The journey requires you to make many smart human decisions as part of the process. There are two main categories for machine learning. Number one is supervised learning, making predictions using data. This is also known as predictive modeling. I recently took an online course where this was presented as ham or spam. The scenario was training an email spam filter to review incoming email and determine if it was non-spam, which we're going to call ham and should be placed in your inbox. So you probably know the rest of the story. The other type of email was spam and either placed in clutter or the trash folder. The goal is to predict a specific outcome. Another view is that the primary goal of supervised learning is to build a model that generalizes. It accurately predicts the future rather than the past. Let's talk about unsupervised learning. This is the process of extracting structure from data and learning how to best present data. So, for example, you could potentially segment students and potential students into clusters that exhibit similar behaviors. You might find three groups of students displaying similar behaviors within each group. So a simple example would be a two-year degree-seeking student cluster might have a renter status as a predictive variable. Master's students might have a home ownership tendency as a predictive variable. Both of these variables is dissimilar between the two groups. Most importantly, there's no right answer. So how does it work? First, you train a machine learning model with training data, also known as labeled data. This is data that has been labeled with the outcome. For example, is the email ham or spam? This is called model training because the model is learning the relationship between the attributes of the data and the outcome. Such a relationship, using our email example, might include the length of text strings, specific text in an email, length of message, etc. Second, you make a prediction on new data for which the label is unknown. That's actually easier than it sounds. A piece of new email arrives. The machine hasn't seen this piece of email before. It predicts that this piece of email is ham, not spam, based on everything it knows. So the bottom line, the model is learning from past examples, using inputs and outputs, and then applying what it has learned to future inputs in order to predict the future outputs. Hopefully that makes sense. Let's talk about the discovery process. How do I choose which attributes of my data to include in the model? How do I choose which model to use? How do I optimize this model for best performance? How do I ensure that I'm building a model that will generalize to unseen data? And can I estimate how well my model is likely to perform on unseen data? Of course, your mileage may vary when answering these questions, as every situation is unique. But again, don't forget, as part of this whole data science exercise with machine learning, the mantra is test, test, test. I want to share with you a lecture that I encountered up on LinkedIn, a LinkedIn slide share. The individual had a lecture called Machine Learning for Dummies. Now, I want to preface that this book does not exist, but it was quite a good lecture, And I'm going to have a download for you at the end of the webinar that will have a link to this lecture up on the LinkedIn shares, and you can go see it for yourself. So basically what we're talking about is the notion of grouping objects as a machine learning concept. The machine has to learn what animal groups belong together. So how does our brain process the images and make groupings happen? Well, that happens via learning. And then afterwards, we can look at a new image and compare with the groups classified to get the closest match. Because we're talking about machines performing a similar operation, this occurs via machine learning. So the animals and the vegetables and the fruits could be grouped based on what the machine has learned. Let's talk about a comparison and some combined powers. So let's compare all of this conversation of machine learning to rules-based learning. I'd be remiss if I didn't do a quick compare and contrast with rules-based predictive modeling. Just as the name implies, rules-based is based on a static set of rules to predict an outcome. It's not really dynamic machine learning. The black box only knows what it knows. Now, one argument for rules-based predictive algorithms are that a few nanoseconds are saved over a machine learning-based predictive algorithm. Yeah, but you give up a lot of power when that happens. And so the answer is what I believe is a unique period in time right now where we have the combination of the maturity of the machine learning field with cloud computing, where you could spin up additional cloud resources in order to provide the speed that you need to make the model responsive for use in a business situation. So for example, a speed to lead situation. I'd also make mention Cray Computing has supercomputers that can also participate in this scenario. It's a killer combination in my point of view. Now for the download that I mentioned, I'd like you to visit LeadScores at www.leadscores.com and download our article that was recently published in the Career Education Review on what is machine learning. For example, you will find the link to the Machine Learning for Dummies lecture, which is a LinkedIn slide share. I want to thank you for attending this lecture on what is machine learning. Please visit us at www.leadscores.com. Thank you very much.